Hello, period 4. Okay, today we're going to do percent of increase, decrease, day 2. So very similar to the previous lesson, although the previous lesson was the amount of change, and today we're going to talk about the percent of error. Again, another formula that we will get to use today. So the percent of error is the difference between an estimate and an exact answer, okay? To find the percent of error, the amount of error goes on top over the actual amount goes on the bottom. Again, the percent of error is the difference between an estimate and an exact answer, okay? So let's look at this first one. It says that Ben estimates it is 10 feet from his couch to his kitchen. The actual distance is 12 feet. What is Ben's percent of error? Go back up to our formula. The amount of error. He thought it was 10 feet. In reality, it was 12 feet. So the amount of error was 2 foot. Over the actual amount, actual distance is 12 feet from the couch to the kitchen. Okay, so when we do 2 divided by 12 in our calculator, we know that's 1/6, but we want a decimal. We're going to get 0.1666. It's repeating. Again, when we want a percent, change the decimal to a percent by moving the decimal twice to the right. So the error, we're going to say, is 16.6, repeating, percent. And we're going to go ahead and just label it error. That was a 16.6% repeating error. Okay. Let's look at the next one. Kevin believes there are approximately 80 puppies at the Humane Society. He calls and finds out that there are really 102. So the actual amount was 102 puppies. What is Kevin's percent of error? The amount of error goes on top. He thought it was 80. In reality, there was 102. So that's an error of 22 puppies. Over the actual, there were really 102 puppies. So when we do 22 divided by 102, we get a decimal that says 0.21568862, blah, blah, blah. There's our decimal. Let's move the decimal twice to the right to make our percent. So that's going to be 21 point. We're going to round to the nearest tenth. So the 6 makes the 5 go up. So 21.6% error. So we're going to round to the nearest tenth for today, okay? Okay, you try the next one. Pause, see what you get. Eric estimates that a baby weighs 8 pounds, but really she weighs 9 pounds. What is the percent of error? Okay, the amount of error was 1 pound. He was close. The actual amount of the baby was 9 pounds. If you do 1 divided by 9, we get 0.1111. It's repeating. Move that decimal twice. 11.1, repeating, percent was the error. Okay, hopefully we're getting the hang of those. The amount of error over the actual. Okay, now what if we have some fractions? Find the percent. Oh, this is the percent of change. We're going back to day 1 notes. Percent of change, okay? Percent of change is, let me go back to make sure I don't say it incorrectly, the amount of change over the original amount. Amount of change over the original amount. Okay, from 3/5 to 4/5, That's a change of 1/5. Everybody agree from 3/5 to 4/5 is 1/5? Over the original, obviously, was 3/5. Think of this as a big old fraction bar. 1/5 divided by 3/5. We don't divide fractions. We keep it, switch it, flip it. So we have 1/3 is the amount of change. Let's not keep it as 1/3. We know that we're going to change that into a decimal, into a percent. 1/3 is 0.3 repeating, which is 33.3 repeating percent change. And from 3/5 to 4/5, that's an increase. Okay. Alrighty, let's look at the next one. Find the percent of change. From 1/8 to 3/8, that's a change of 2/8. I would not simplify. Over the original amount is 1/8. Again, think of this as a division bar. So 2/8 divided by 1/8. We don't divide fractions. We keep it, switch it, flip it. So we have 2 over 1, 2 wholes is 200% change, and it went from 1/8 to 3/8. So again, that's an increase. Okay, so fractions, we're going to do just the same. Okay, let's look at a few word problems. Josh claims that a change from 30 to 60% is a 100% increase, but a change from 60 to 30 is only a 50% decrease. Is Josh correct? Why or why not? Use math to explain and then also read about it. Okay, let's say his first claim is that a change from 30 to 60 is a 100% increase. Okay, so from 30 to 60, okay, percent of change. The amount of increase is 30 over the original is 30. That's 1 whole, which is 100% increase. He was right about that one. Let's look at claim 2. He claims from 60 to 30 is only a 50% decrease. Okay, percent of change from 60 to 30 is a 30% decrease over the original of 60. 30 divided by 60 is 0.5, which is 50% decrease. He's correct on that one as well. So Josh is correct. Okay, the original amount here makes the difference. In A, the original amount is 30, as is the change, which is 1 whole. In B, 60% is the original amount. So 30 over 60 is half, or 50%, okay? So that original amount is what makes the difference here, okay? Alrighty. Go ahead and check Canvas, see what else we completed in class today, if anything. If not, you may start on your virtual